Hello everyone, I welcome you all for SVK tutorials. Those who are not subscribed to my YouTube channel, do subscribe to my YouTube channel. This is the prime time to watch my YouTube channel since I will be solving the model question paper. So in this video, I will be solving the module 3, which is of vector space and linear transformation. One more important thing I need to tell, this module is for both CS stream and electronic stream. Both can refer this video. So it is mainly for CSE and electronics stream. Now we shall move on to the solution part. So the solution is we are discussing on the vector space and linear transformation. So moving on to question number 5a, prove that the subset W equal to x, y, z such that the W is defined as x minus 3y plus 4z equal to 0. X minus 3y plus 4z equal to 0 of the vector space R cube is a subspace of R cube. So here we need to prove that whatever the given subset W is a subspace of R3. So you should know that what is a subspace. It should satisfy three conditions. One is it should be a null space, then it should satisfy vector addition, and it should be an scalar multiplication. If these three satisfies, then we can say that it is a subspace of subspace. Okay, so moving on to the solution here, consider the given W. I have written the W in vectors. I have written the vectors in the form of x, y, z such that is defined as x minus 3y plus 4z equal to 0. So considering the condition 1, that I need to show that it is a null space. So to show that, I will be defining x, y, z equal to 0. So 0 belongs to W. If I consider 0, 0, 0 vector belongs to W. So that implies if I substitute x, y, z values as 0 here. So just substituting x as 0, y as 0, z as 0, and that value will be 0. Therefore, LHS equal to RHS. Therefore, I can say that first condition has been satisfied here. Moving on to the second condition, that is I need to prove that vector addition. You need to consider two vectors. So both the vectors should be same here. So means W1 plus W2 should also satisfy the given condition here. So for that reason, I have considered W1 as it is. For that reason, I have been considered W1 as x1, y1, z1. W2 as x2, y2, z2. Then according to the definition, I have defined W1 as like this: x1 minus 3y1 plus 4z1 equal to 0. Then I will solve for x1. x1 is 3y1 minus 4z1. Similarly, I will be solving for W2. I got x2 as 3y2 minus 4z. Now I will be considering x1 plus x2. I have considered x1 plus x2. What is x1 I know? What is x2 I know? I am just substituting those two things. Then I am separating the term called y and z. That is what I have done. This is y part and this is z part. From that I have taken out 3 common. From this two terms I have taken out minus 4 common. So finally I left out with x1 plus x1 plus x2 is equal to 3 times of y1 plus y2 minus 4 times of z1 plus z. It is as same as the definition called given definition, x equal to 3y minus 4z. So for that reason, I can say that W1 plus W2 is closed under vector addition. So finally, I can say that as it is belongs to W, therefore W is closed under vector addition. Similarly, I need to prove that scalar multiplication. Just whatever you consider scalar quantity, that value will be multiplied with a vector W. Okay, let us consider a scalar quantity alpha. So for that alpha, this alpha will be multiplied with W1. I have defined W1. Then alpha W1 becomes what? Alpha x1, alpha y1, alpha z1. According to definition, we can say that W is also closed under scalar multiplication. Therefore, W is a subspace. This is the way of answering the question number 5b. So moving on to question number 5b, determine whether the given matrix is a linear combination of these three matrices in the vector space M22 means 2 cross 2 matrices. M22 means 2 cross 2 matrices. Okay. So consider the given matrix. Consider the given matrix. This is what consider given matrix, which can be expressed as sum of linears of combination of these matrix. So I need to express this. So I can, for that reason, so whatever the given matrix I have considered in left hand side, which will be equal to C1 times of this matrix plus C2 times of this matrix plus C3 times of this matrix. Whatever the matrix they provide, you need to go with the same procedure of solving this matrix problems. So then C1 value is multiplied to each element of this matrix. C1 value is multiplied to each element of this matrix. C2 is multiplied to each element of this matrix. C3 is also multiplied to each element of this matrix. So that is what I have done in this step. So now I will go with addition of the matrix. So that is A11 means first row first elements of each matrix will be added here. So first row first element, first row first element, first row first element. So first row first element, first row first element, first row first element is added. So I got C1 plus 2C2. Similarly, first row second element, first row second element, first row second element. If I add this, I got minus 3C2 plus C3. Similarly, I am going to add second row first element. So similarly, adding all these things, we are going to get this element. This is what we got. Similarly, for the last value as like this. So then I will name that as equation star. So did you got? So just I am adding these elements. Then I will be equating, as we have equal matrix. We know the definition of equal matrix. Both are 2 cross 2 matrix. Both left hand side and right hand side as 2 cross 2 matrix. So I can equate the first element with this first element. That is what I am doing. So similarly, 7 is equated with this element. So all these things we have done and name that as equation 1. So just equating the elements. So after that, I am going to write down augmented matrix. I will be writing augmented matrix. What is augmented matrix means? The coefficient of C1, C2, C3. The matrix A is coefficient of C1, C2, C3. In first row, I have the coefficient of C1 as 1, coefficient of C2 is 2, coefficient of C3 is 0. There is absence of C3, that's why it is 0, colon. So the constant value, the matrix B is constant matrix. This is the matrix B minus 1. Similarly, the second row will be filled with the second equation. C1 value is 0 here. There is no C1. Since the coefficient of C1 is 0, so I have written 0, minus 3, 1, 7. Similarly, I can write the remaining rows. So then I will go with the row reduced echelon form. I will try to make these elements as 0. Make these elements as 0. Try to get upper triangular matrix. So therefore, for that reason, I am going to do operation R3 changes to R3 minus 2 times of R1. So already the second row first element is 0 here. Need to make these two elements as 0. So for that reason, R2 has been changing as what? R. So for that reason, R3 is changing as what? R3 minus 2 times of R1. Will be multiplying the first row by minus 2. So I got the value as 0. So 2 minus 2 will be 0. Just for R3, I will be going with R3 as what? R3 minus R. I will be going R4 as what? R4 minus R1. So I got directly 0. So similarly, each row element will be operated. So this value becomes 0 minus 0 minus 2 times of 2, which is nothing but minus 4. So that is what I have written, minus 4. Then 2 minus 0 will be 2. Then 8 minus of 2 times of minus 1, which is nothing but 8 plus 2, which is equal to 10. That is what I have written here. Similarly, the last row will be operated as it is. So just subtract with R1. So 1 minus 1 is 0, 2 minus 2 is 0, 0 minus 0 is 0, minus 1 minus 1. Minus of minus 1 becomes plus 1. So sorry, make this correction. Now minus of minus 1 will be plus 1. So it will be 0. This value is 0. So this is 0. So therefore, after calculating this, I yet to need to make this value as 0 by using R2. So I will be operating R3 again. R3 will be changes to 3 times of R3 minus 4 R2. I'm going to get this matrix. So from this matrix, I will find out rank A. This is what rank A I can find out from this matrix. So what is rank means? So we need to find out number of non-zero rows. So number of non-zero rows is 1, 2, 3. So that's therefore rank A equal to 3. Similarly, now I will find out rank of augmented matrix. This is what rank of augmented matrix. Number of non-zero rows is 1, 2, 3. So I got rank of augmented matrix is also 3. Number of unknowns C1, C2, C3. So 3 unknowns we have. So for that reason n equal to 3. So there, as we have rank A is equal to rank of augment matrix equal to 3. So we can get the solution, unique solution we can get. Just solve that equation, resubstitute this matrix again, resubstitute this matrix, that is C1 plus here 2C2 plus 0 C3. That is what I have written. C1 plus 2 C2 equal to minus 1. Similarly, from second row, minus 3 C2 plus C3 equal to 7. This first column values are multiplied by C1. This second column are multiplied by C2. The third column values are multiplied by C3 and or add all the three values. So therefore, that is what we have got the three system of equation. Solving this system of equation. So from the last equation, I got C3 value as 1. So I will substitute this C3 value in the above equation. So I got, so that is what, minus 3 C2 plus 1 equal to 7. I have substituted. So simplifying this, I got C2 values minus 2. Substituting C1 and C2 value and C3 value here in the above equation. If I substitute C2 value, I got C1 value as 3. So this is what the values of C1, C2, C3. After getting these C1, C2, C3 values, if you substitute back to the equation, these two matrices will be equal, one and the same. Therefore, I can say that the given matrix has a linear combination. Thus, we can say that the given matrix can be expressed as a linear combination. So, moving on to next question. So, question number 5C. So, find the matrix of the linear transformation. So, T. So, T is having the value minus 1, 1, 2 changes to minus 1, 0 to 2. So, which is nothing but place from R2 to R3. So, I think I have discussed this problem earlier. You can go through my previous video. I have solved this problem separately. You can refer my previous video for more. So, moving on to next question. Question number 6A. Show that the set S is 1, 2, 4, 1, 0, 0, 0, 1, 0, 0, 0, 1 is linearly dependent. So what is linearly dependent means? If you get the inconsistent means, if the solution is infinite, we can say that it is linearly dependent. So consider the given subset, given the set, and try to express in linear combination as it is like this. Whatever I have expressed is expressed in this form. C1 times of a column matrix 1, 2, 4. This is I have written this values as in terms of column matrix, plus C2 times of another column matrix, plus C3 times of another column matrix, plus C4 times of another column matrix, which is equal to 0. This is what linear combination. Now I am yet to find values called C1, C2, C4. So I will be, whatever I explained in the previous problem, in the same manner I am expressing. C1 values will be multiplied both these values, C2 values, and similarly C4 values. So finally, addition of all the first elements C1 plus C2 plus 0 C3 plus 0 C4. That is what I have written. I'll go to last value 4 C1 plus 0 C2 plus 0 C3 plus 0 plus C4 equal to 0. That is what I have expressed. So from this system of equation, I can write down the matrix like this. I have written the matrix. Then I will go with the row reduced echelon form. So I will be applying a row reduced echelon form. Find the rank of the matrix. So from this matrix, I got the rank of the matrix as what? The number of non-zero rows is 3 here. The number of non-zero rows is 3. But how many unknowns we have considered? C1, C2, C3, C4. So n equal to 4 is less than that value. Since the rank is less than that value, we can say that It is an inconsistent and it has infinite solution. So solving this equation, so rewriting this equation form, rewriting this matrix in equation form, I am going to get 3 equations. So from that I am going to solve for C4. I will consider C4 value as K1. I will be substituting that C4 value in equation 3. I got C3 value as K1 by 2. Substituting C3 value in equation 2, I am going to get C2 value as K1 by 4. And substituting C2 value in equation 1, I am going to get C1 values minus K1 by. Therefore, I can say that the given set is linearly dependent. We can also solve in another manner. If you find the determinant, if the determinant of the matrix, whatever I get the matrix here, this matrix, if this matrix, find the determinant of this matrix, if this determinant is not equal to 0, we can say that it is linearly dependent. If it is equal to 0, then it is independent. That's all. So this is a way of solving, another shortcut of solving the method for linearly dependent and independent. Moving on to question number 6b. Prove that the transformation, before moving on to 6b, kindly I request you people to do subscribe to my YouTube channel, and you can go through my previous videos for the solution of model question paper. So I have uploaded already module 1 and module 2 completely. You can go through them. Question number 6b. Prove that the transformation T R2 to R2 defined by a transformation T of x comma y equal to 3x comma x plus y is linear. Find the images of the vectors 1, 3 and minus 1, 2 under this transformation. So they have been given the transformation T, transformation they have been provided from R2 to R2. I'll be noting down that transformation. So then I will be considering u and v. So let u equal to x1, y1, v equal to x2, y2. So from that I will be find out transformation of u. T of u will be equal to t of x1 comma y1, which is equal to 3x1 comma x1 plus y1. What I am doing, just I am using this definition. In place of x I have x1, in place of y I have y1. So just substitute in place of x as x1, in place of y, y1. So for that reason, comma x1 plus y1. So similarly, T of v will be equal to 3x2 comma x2 plus y2. So I will be finding out transformation of u plus v. So what I am going to prove means T of u plus v will be equal to T of u plus T of v. If these two are equal, we can say that transformation exists, or along with the scalar multiplication. So first I am going to prove that vector addition is satisfied. Then we can say that the transformation to be a linear transformation, scalar multiplication should also satisfy. So T of u plus v. So just u plus v is nothing but what? I am adding the corresponding coordinates x1 plus y1. Sorry, x1 plus x2. So x1 plus x2 comma y1 plus y2. So you can now consider this value as x and you can consider this value as y and apply this definition. So 3 times of x1 plus x2 comma x1 plus x2 plus y1 plus y2. So expanding that expression, I am going to get 3x1 plus 3x2, x1 plus y1. I am rearranging x1 plus y1 plus x2 plus y2. So I will be naming this as equation 1. Now I will be finding out transformation of u plus transformation of v. So apply the definition. Transformation of x1 y1 will be what? 3x1 comma x1 plus y1 plus transformation of x2 y2 will be what? 3x2 comma x2 plus y2. So from that I can get what? 3x1, just addition of these two matrix. What I am going to get? 3x1 plus 3x2, 3x1 plus 3x2. Similarly, addition of these two, what I am going to get? x1 plus y1 plus x2 plus y2. From equation 1 and 2, I can say that both are equal. Therefore, transformation of u plus v will be equal to transformation of u plus transformation of v. Now let us consider transformation of alpha u, which is nothing but transformation of t of alpha times of u is what? x1, y1. Multiply this alpha inside for both the coordinates. I'm going to get T of alpha x1 alpha y1. Then apply the definition, that will be 3 alpha x1 plus alpha y1. Name that as equation 3. Similarly, find out alpha T of u. You know what is T of u. Write down that. Then multiply finally alpha inside. So we are going to get equation 4. From 3 and 4 I can say that both are equal. Therefore, I can say that as these two are satisfied, these two conditions are satisfied, I can say that the given transformation is linear transformation from R2 to R2. To find the image of 1, 3. So now you can consider 1, 3 as x as 1 and y as 3. That is what I am going to do. Transformation of 1, 3. Just substitute x equal to 1. 3x, that is 3 into 1, comma x plus y, 1 plus 3. So I am going to get 3, 4. This is the transformation for 1, 3. Similarly, find out the transformation from minus 1, 2. So from minus 1, 2, I am going to get minus 3, 1. So this is the transformation for the given values. Moving on to the last question. Show that the function f of x is equal to 3x minus 2 and g of x is equal to x are orthogonal in Pn with inner product fg is equal to integral 0 to 1 f of x g of x dx. So I wish not to miss this problem. You can easily solve this problem. All the problems are very easy. If and only if you understood the concept very properly, you can answer any problem in vector space. So this is one of the problem of inner product. So they have been given f of x, what is f of x and g of x, note on that. So then already they have defined inner product as which is equal to integral 0 to 1 f of x g of x dx. Substitute what is f of x, what is g of x. That is what I have done and expand that. So after expansion I got this. Then integrate with respect to x. After integration I got 3x cube by 3 minus 2 times of x square by 2. 3 and 2 get cancelled. You are left out with what? X cube minus x square. Limit x equal to 0 to 1. Substituting the limits, 1 minus upper limit 1 minus 1 minus lower limit 0 minus 0. So 1 minus 1 is what? 0. 0 minus 0 is 0. So final answer is 0. So the given inner product is equal to 0. Hence we can say that the given function is orthogonal. So this is the way of solving the given problems, and it is easy to solve. CS and EC students, so you can easily solve this problem. If you have any doubts, you can put a comment. I will try to resolve your doubts. Thank you all for watching this video and share this. Don't forget to share this video with your friends. So I wish you all the very best for your upcoming examination. Thank you all for watching this video.